So at the end of the last video, I left you with this possible interpretation of the mean as the fulcrum point of a bunch of observations spread out along sort of a seesaw kind of situation. I'm not sure if it was clear. Let me try and point out a little bit more what that means. So we have again a bunch of numerical data, numerical numbers, and so what we can do is we can place each one of those numbers on its proper position or on a ruler. So let's say we have one observation that would belong on this position, another one in this position, three in this position, and so on and so on. If we place them along the ruler, each one of them in the proper position, then the mean corresponds to the one position that is going to keep the whole system in balance. So the whole thing will in fact may oscillate, but it's not going to fall either way. Now I admit that was a pretty pathetic kind of animation, but I hope it clarified a little bit what we're talking about. If not, we can always talk about this a little bit more. However, there are other interpretations which sometimes can be good, sometimes cannot be good. Okay, so for instance, we can think of the mean as what we obtain by taking the total of everything we've observed and dividing it equally among each of the observations, right? Well, that's how we're computing the mean. We add up all the numbers and divide by the sample size. Now, this is often useful and is often meaningful, and you can make sense of what it is. For instance, if we're talking about money, it would make sense to think of adding up all the money that you have observed in each of the persons and dividing it equally. It's sort of a socialist kind of approach to things. But in other situations, it may not be that clear what we're talking about. For instance, let's look at even the simplest kind of mean, the mean height of people. So we have a whole bunch of people, each one of them with a different height. And let's say we want to compute the mean height of this group of people. What are we really doing when we're doing that? Well, what we're doing is we're laying those people horizontally, head to toe. And again, this is a bit of a picture, so it's not exactly done. But this is the idea. We're putting them, if you want, along the street, one adjacent to each other. And then we're figuring out what the total length that would be spanned by these people would be, figure out what this total length is, and then we're going to divide it into the number, in this case 6, of equal chunks of equal length. What does that really mean? Well, for instance, we can see that the lady on the right hand side here is very close to being close to the average. All right, so she's an average person, but in what sense, right? And really, how can we redistribute the height among people? Are we going to chop off the legs of the basketball player and then put them below the lady who is trying to do some fitness exercises? And it doesn't really make a lot of sense in this respect. So you want to be careful on how much importance you give to the mean, and how and not to make its interpretation too general. Another problem having to do with the mean is the fact that it can be affected by outliers. And what do I mean by that? An outlier is an observation which is rather different from the rest, from the bulk of the observation, something a little bit unusual. Okay? And because the mean uses all of the observations and uses them all in the same way, it can be affected by that. So for instance, if we go back to our set of data from before, we notice that the mean would have been in that position. Actually, this is a little bit different. So let's consider this set of data, which consists of a bulk of observation on the right hand side and two unusual ones on the left hand side. Because of that, we have to place the fulcrum quite a bit to the left towards those two extreme values in order to make everything balance. But if we take those two observations on the left away, and we're left only with these observations which form the bulk, then the mean is going to be moved quite a bit. And therefore, just those two observations only are capable of moving the mean quite a bit. And this is something in some situations is not a very good thing. Okay, so which average should we use? Well, there are many more averages besides the mean and or the arithmetic mean. As I mentioned, there are other means like the geometric mean, for instance, that we are not going to look at, but it exists and it does have its role in medical research. But there are many averages that one can use. Okay, no average is the best one. Each one of them has its pluses and minuses, and if you have a look at the textbook, you'll see a little table that compares their advantages and disadvantages. No averages hold all the truth. Providing many averages may be useful, but sometimes can be also a little bit too much. Okay, so what you want to do is use whatever provides good information, and you'll have to decide each time what that means. Okay, and remember that variability, which we're going to have a look at next time, can have more information than averages, so pay attention to that one as well.